With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, let us have a look at the question. First of all, so the question says that why do Mn2 show maximum paramagnetic character amongst the bivalent ions of first transition series? So in this question we need to explain that why manganese plus 2 show maximum paramagnetic character among all the other bivalent ion of first 3D transition series, right? So let us try and understand before we solve this question that paramagnetic nature, paramagnetic behavior is directly related to magnetic moment, right, which is equal to under root n into n plus 2, right? So more the magnetic moment, higher will be the paramagnetic character, and where n is the number of unpaired electrons, right? So more number of unpaired electron means higher will be the magnetic moment and more will be the paramagnetic, that particular ion or compound will be, right? So to check that why manganese plus 2 will show maximum paramagnetic character, we'll have to first of all write down the electronic configuration for all the ions in third transition series, 3D transition series, sorry, in first transition series, which is 3D transition series, right? So Sc plus 2, we have scandium, then we have titanium, then we have vanadium plus 2, okay, then we have chromium, and then we have our manganese, right? Then Fe plus 2, okay, and moving on to the next one, we have cobalt, right? Then we have nickel, okay, then we have copper, and at last we have zinc plus 2, right? So let us try and write down the electronic configuration. Okay, so let us try and write down the electronic configuration for all of them. So we have for scandium plus 2, it will be 3d1, titanium will be 3d2, vanadium will be 3d3, chromium will be 3d4, similarly manganese will be 3d5, right? Similarly, if you just have to write down for Fe, it will be 3d6, 3d7, nickel will be 3d8, then we have 3d9, and at last we have completely filled d orbital for zinc, that is 3d10, right? So this is how we can write down the d orbital electrons for all the ions here, right? And now let us have a look at the number of unpaired electrons that they have. Okay, unpaired electrons. Okay, so the first one is scandium plus 2, and d orbital has 1 electron, which means it has only one unpaired electron, or only electron that is unpaired, right? Here we have 2, here we have 3, then 4, and then here we have 5, right? For iron, to understand it, we'll have to draw the electron filling diagram, right? So it will have 6, so 1, 2, 3, 4, 5, right? So 5 5 electrons with similar spin, and then 6th will be like this. So we have 1, 2, 3, 4. 4 electrons that we have here is, we can say, is unpaired, right? Similarly, for 3d7, we will have, again, let me just draw it for this also to make it clear. So we have 1, 2, 3, 4, 5, 6, and 7, right? So 3 unpaired electrons here, we can say. Similarly, for 3d8, now I guess you must have sensed the pattern. So it will have 2, this will have 1, and this will have 0, right? So unpaired electron, first of all, increase till manganese, and then it starts decreasing from manganese to zinc, which has 0, right? So the magnetic moment will be highest in the case of manganese, right? Because it has the highest number of, we can say, unpaired electron, and that will be equal to, so magnetic moment will be equal to, so the value of n here is equal to 5, so it will be 5 plus 2, under root 5 into 5 plus 2, which will be 5 into 7 is 35, so under root 35, which means 5.9 bm. Okay, so this is the highest magnetic moment that we have, just because all the other divalent ions that we can see in 3D transition series do not have as much unpaired electron as manganese has. Okay, so this is how we can understand that why manganese plus 2 will show magnetic character which is maximum in 3D transition series. I hope this is clear to you. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.